Hello class. So since I'm out, I'm going to do this video lecture. We're going to see how it goes. I've never quite done anything like this before. So chapter 4, which we're going to be starting, really deals with aqueous solutions, talking about having reactions. Well, what happens when we put a chemical into water? Well, the first category is talking about electrolytes. Okay, our first concept is a strong electrolyte. Okay, so if we take sodium chloride, okay, which is normally a solid, and we add water to it, what's going to happen to that? Well, as it turns out, sodium chloride is a strong electrolyte, which means it's going to completely break apart once we put it into solution. So you're going to have sodium ions, and you're going to have chlorine ions. Okay? So that's a strong electrolyte if it completely breaks apart. Okay? We also have weak electrolytes. Okay, so something like our weak acid, our HF. Okay, so when we put that into solution, okay, it doesn't go to 100%. We draw this double arrow to say it's in equilibrium. So some of it will fall apart and form our proton plus our fluorine. Okay, but not all of it. A lot of it will remain as our hydrofluoric, our HF. So those are weak electrolytes. They don't completely fall apart. Next we have our non-electrolytes. Okay, this would be something like our sugar, our C6H12O6. When we added water to that, okay, turns out it doesn't fall apart at all. Not one bit. So over here we still have our glucose, C6H12O6. Nothing happens. The classic demonstration for looking at whether a solution is a strong, weak, or non-electrolyte is one of these if we can actually conduct electricity through that. So here we have a beaker full of distilled water. We have our light bulb, which is connected to our power supply, and then we have these electrodes we can drop in. So in pure water without any other substances in it, if we just drop this bulb in, we will see the light bulb stays out. There's no charge carriers in that aqueous solution to carry the charge between these two electrodes to allow the current to flow through the filament in the bulb so the bulb does not light up. Okay, so we need charge carriers in the solution to actually make this filament light up. So strong electrolytes, which will completely fall apart, will give us the most charge carrier. So here we have our salt. Okay, so now if we add a little salt to this solution, okay, so we're going to pour in some, and we're going to stir it up to get it to go into solution. Okay. Add just a little more maybe. So all that sodium is breaking into all the different ions, into the sodium, into the chlorine, and so now there should be charge carriers into the solution. So now let's lower it down into our solution. Oh, and look at that, the light bulb comes on. It's a nice bright light, okay, which means we not only have charge carriers, but we have a lot of charge carriers because the bulb is so bright. Okay, so we're carrying a lot of that current through these two filaments. Okay, so that's a strong electrolyte. All right, let's look at some of the other ones that we have. Okay, so those are strong electrolytes. So here we have our distilled water. So then let's try our sugar. Okay, so that's our glucose. It's a weak electrolyte, a non-electrolyte, right? So now we have our sugar. All right. Now we need to rinse this off for just 1 second so we don't contaminate. Perfect. And then let's stir up our sugar in our beaker. So the sugar, when it goes in, it's not going to fall apart or break apart in any way. So really there's not going to be any charge carriers. So the ideal thing to see is our light bulb is going to stay out. So we still have a little down there that haven't dissolved, but let's go ahead and give this a try for our non-electrolyte. Okay, so we're going to lower it down. There we go. See, we've added sugar and our bulb is still out. We don't see any light coming through it. So that is our non-electrolyte. There's no carriers. The sugar doesn't break apart, so it can't carry any of the voltage. Alright? So there's an intermediate between our sugar, which is our non-electrolyte, and our salt, which is our strong electrolyte. And this is our weak electrolyte. So we have our distilled water again. Alright? And weak electrolytes are generally going to be something like our weak acids, our weak bases. Okay, so there's a table in your book which gives you all your strong acids, your hydrochloric, your sulfuric acid, your nitric acid. Those are all strong electrolyte because strong acids completely break apart when you put them in the solution. But things like vinegar, which is acetic acid, okay, it's a very weak acid, so it has that equilibrium between being in that protonated stage and that unprotonated stage. So we're going to add some vinegar to our distilled water. So now we have a little bit of this weak electrolyte present. Oh. Snafu on the video. Maybe we have to edit. Who knows? We're going to mix it up, and then we're going to put it in our electrodes over here. Alright, so we're going to lower our light down into this weak electrolyte. Oh, I don't know if we added enough. We may have to make our electrolyte a little stronger here, so let's maybe not add so much distilled water. So let's add a lot of our acetic acid. This is only 5%, so really it's mostly our water, very little bit of our acid. So let's try this mixture. So remember, weak electrolytes, most of them are not our charge carriers. Only that very small fraction that actually is going to break apart is going to be our charge carrier. Okay. Now, I can see it glowing, but for video's sake, we may actually have to turn it out. Can you guys see that? Okay, so it's very faint. That's our weak electrolyte. Okay, so we have just enough of those ions that break apart from our weak acid that will be able to carry some of the charge. Not all of it like we saw that strong electrolyte, but just a little. Okay. So this is your first demonstration in terms of Chapter 4 and learning about aqueous solutions, being able to classify them as weak electrolytes, strong electrolytes, or non-electrolytes. I'll see you guys on Friday.